This is the 2013 NAPLAN paper, non-calculator section, question 16. This graph shows three corners of a parallelogram. So we can see 1, 2, 3 corners. Which of these points is the fourth corner? You can pause the video and try the question. Now, we know that with a parallelogram, opposite sides are parallel. So if you want, you can join up the sides that are already there. So I'm joining up these two dots here with a red line and the two dots down here with a blue line. If you want, you can put in the other lines as well. And by putting in the other lines that are parallel to these existing lines, we will actually find the fourth point. So if I put the fourth point at this intersection here, we can see that the fourth point will actually be the point 6 across, 4 up, which is the point 6, 4. Now, you could do this question by drawing it as I have. The other way that you could do the question is you can just look at these first 2 points here, and to get from the bottom point to the top point, you go up 3 and across 1. So therefore, for a line to be parallel to that red line, we start here at this bottom point and go up 3 and across 1. And put the red dot there, meaning that that is the fourth corner. Now for question 17 in the 2013 non-calculator paper. In the past month, 5 houses were sold in Liz's neighbourhood. The selling price for each house is listed below: $225,000, $225,000, $355,000, $275,000, and $380,000. And the question is, what was the median selling price for these 5 houses? Now, the median is the middle score when all your scores are placed in ascending order. Now, if we look at the scores that we've got 225, 225, but the next in order, if you put them in order, the 275 should actually come before the 355. So we really need to swap these two prices here so that they're in ascending order. So I'll just do that now. So I'm just starting to write these prices out in ascending order. So the first price is 225. The next lowest price is 225. Then we've got 275,000. Then we've got 355,000. And the most expensive house there is 380,000. So now these prices are in ascending order. Now the median score is the middle score. So what we can do is just cross off some numbers from either side. So I cross off these 2 numbers there. And then I can also cross off these other 2 numbers. So just coming in from the sides, you can just, cross off a number from either side. So I'll just put in another cross there, just in a sec. So that leaves me with my middle score being, so I've crossed off 225 and 380, and I've crossed off 225 and 355. Therefore, my median score is here. It's 275,000, because that's the middle score. Now for question 18. Question 18 says, which of these expressions below is equivalent to negative bracket x plus 2? You can pause the video and try the question. Now, this negative out the front of the bracket means that you've got a negative 1 in front of the bracket x plus 2. So we've got negative 1 times x, or you can just say negative x. So you've got to have a negative x, and then we have negative 1 times positive 2, which is negative 2. So if we expand negative x minus 2, we go negative x, so we get minus x, and then we do negative 1 times positive 2 is minus 2. So the answer will be negative x minus 2, which is this first answer here, because we need to take the negative of everything inside the bracket. So we've got negative x and negative positive 2, which is negative 2. Now for question 19 of the 2013 non-calculator paper. Now we've got that 10x, which means 10 times x, is greater than x squared. And x squared means x times x. So what is the largest whole number that x can be? You can pause the video and try the question. Now what we can do, we can try some values of x. Now we know that, for example, we might try x is 10 because 10 times 10, we'll try that first. So if x equals 10, then on the left-hand side, we've got 10 times 10, and we put a greater than symbol. And on this right-hand side, we've got 10 squared. Now, when we work out the left-hand side, 10 times 10 is 100. Put the greater than symbol. And 10 squared is also 100. So is 100 greater than 100? No, that's not true. It's actually false. 100 is not greater than 100 because 100 is equal to 100. So 10 is not the answer. So let's try if x is 9. So let's try if x is 9. So looking at the left-hand side, we've got 10 times 9. Now 10 times 9, if we worked it out, we get 90 on the left-hand side. We'll put our greater than symbol in. And on the right-hand side, if x is 9, we get 9 squared. Now 9 squared is 81. So is 90 greater than 81? Yes, it is. That statement is true. So the largest whole number that x can be is 9. Now, of course, the statement is true, for example, if x is 8. So if x is 8, on the left-hand side, you'd get 10 times 8 is 80. And on the right-hand side, you'd get 8 squared, or 8 times 8 is 64. And we know that 80 is greater than 64. The statement is true, but 8 is not the largest whole number that x can be. Hence, 9 is the biggest number that it can be. Looking at question 20 in the 2013 non-calculator paper. Meg has an electronic photo display. Each photo remains on the screen for 9 seconds. Meg has 100 photos on her memory card. How many minutes will it take to complete the display of all the photos? You can pause the video and attempt the question. Now there are many or a few methods that you could use to do this question. I'm going to show you one particular method here. Now, if one photo takes 9 seconds, then we have to work out how long 100 photos takes. What I'm going to do, I'm actually going to work out next, instead of 100 photos, I'm going to work out how long 10 photos will take. So if one photo takes 9 seconds, then 10 photos should take 90 seconds, because to go from 1 to 10 we times by 10, okay, and so we do 9 times 10, so 10 photos, I'll just fix that page, sorry. So 10 photos will take 90 seconds. Now 90 seconds is more than a minute, because 60 seconds is 1 minute and the other 30 seconds will be half a minute. So 90 seconds is actually 1.5 minutes, and I can write that as a decimal as 1.5 minutes. Now the question is to work out how long it takes to display 100 photos. So we know that 10 photos takes 1.5 minutes. So we need to go from 10 photos to 100 photos. How do we go from 10 to 100? We times by 10. So if 10 photos takes 1.5 minutes, we can do 1.5 minutes times 10, and that's 15 minutes. So 100 photos will take 15 minutes. So I've just shown here how I'm going from one line down to the next. We're timesing everything by 10. Okay, so 1.5 times 10 is 15 minutes, because 10 times 10 gave me 100 photos. And 1 times 10 is 10 photos, so 9 times 10 was 90 seconds, and we just changed the units across there. Now for question 21 of the 2013 non-calculator paper. The table below shows a pattern of shapes, and we can see we've got 3 shapes there. Shape number is represented by the pronumeral N, and number of squares is represented by the pronumeral S. Notice we've only got 1 square here, so S is 1. In this second diagram, we've got 1, 2, 3, 4, 5 squares, so S is 5, S, because we've got 5 squares. And in the last diagram, if you count the squares, you've got 9 squares, so number of squares, S equals 9. So you have to work out the equation which is used to show the relationship between S, the number of squares, and the shape number. So you can attempt this question now. Now to do this question, we'll look at the first equation here, that S equals n plus 4. Now you can try this with any of the shapes. I'm just going to use the first pattern here. So we're going to try this formula. So if S is 1 and n is 1, and we're trying this formula. So in this first shape here, we've got n is 1 and S is 1. So I'm going to use this formula, S equals n plus 4. Again, S is 1 and n is 1 using this first shape. So trying this formula, we replace the S with 1 and the n with 1. Now we're getting that 1 equals 1 plus 4. That is not true. This is saying that 1 equals 1 plus 4 is 5. 1 does not equal 5. So this formula here, or this equation here, is incorrect. So what we're going to do, we're going to try the second equation. And the second equation is S equals 4n, which means S equals 4 times n. So we're going to try it again for this first shape, where n is 1 and S is 1. So let's try the formula, S equals 4 times n. So S is 1, so 1 equals 4 times 1. In other words, 1 equals 4. Now we know that is not true as well, so that's false. So this is not the formula. Let's try the next formula, S equals 4n plus 4. Again, we'll use this first shape here, where n is 1 and S is 1. Now substituting into this formula, S equals 4n plus 4, we get 1 is equal to 4 times 1 plus 4. Now 4 times 1 is 4, plus 4 is 8. Does 1 equal 8? No, it doesn't. So that is not the formula. So it's got to be this last one, and we'll just check it. So S equals 4n minus 3. For the first shape, we've got that n is 1 and S is 1. So let's substitute those into the formula. So S is 1 and n is 1. So we go 1 equals 4 times 1 minus 3. Now 4 times 1 is 4. Take away 3 is 1. So does 1 equal 1? Yes, it does. So this formula here is the correct formula, because this statement here is true. Now you could have used S is 5, n is 2, or S is 9, n is 3, for all of these different formulas to see which one worked. And you would have ended up with the same answer. Now, question 22 of the 2013 non-calculator paper. The top and bottom faces of this object are both regular 7-sided polygons. So we've got 7 sides, 1, 2, 3, 4, 5, 6, 7. We've also got 7 sides on the bottom, even though you can't see them all. And all the other faces that we can see here, like 1, 2, 3, that's a face. There's another face and another one. They're all isosceles triangles, and you have to work out how many edges that the object has. You can pause the video now. Now, when you count the number of edges, you need to be systematic about it. In other words, you should just perhaps look at the top face here. So how many edges here on the top? We've got 1, 2, 3, 4, 5, 6, 7 edges. So the top face has 7 edges. The next easiest one to do would be the bottom face. Now, it does say that the bottom face is a 7-sided polygon, so it will also have 7 edges. So we've got 1, 2, 3. They're the only 3 that we can see, but there will be 4 at the back. So the bottom face also has 7 edges. Now we just have to count how many edges in this middle face here. So we can see that we've got 1, 2. I'm not going to count this one up here at the top because I've counted it before. So for this first edge here, I've got 2 other edges, 1, 2. For this other edge up here, I've got 2 other edges, 1, 2. So because I've got 7 edges up here, I must have 2, 4. I must have 2 lots of 7, which gives me 14 edges. So adding these all up, I've got 7 plus 7 plus 14, which is 28 edges.